Okay, let's get started. Welcome to what I think you will find is going to be a very informative webinar on the use of FARO, Orbis Premium, and TopoDOT to dramatically improve urban surveying workflows. Thank you for taking the time out of your busy schedule to attend this session. We will start with housekeeping, then brief introductions, followed by a short presentation on the development of a new surveying guide for the Departments of Transportation here in the US. This will be followed by the main presentation from Point3D on an impressive urban surveying case study. First, the usual housekeeping information. I'm sure you're all familiar with all of this. Take a minute to review. We will have 3 polls today and an exit survey. You'll receive a link to the webinar if you are registered. So those are the main issues. Let us know if you're having any serious problems. We'll try to help you out. Okay, for those who I have not met, I'm Gene Rowe, the founder of Lidar News. I'm a civil engineer with main interest in surveying, engineering, and mapping. I started surveying with 100-foot steel tape, a plumb bob, and a slide rule. So you're going to see some different equipment today. My son Nathan and daughter Sarah have been assisting with this webinar. Thanks to them, I'll be making a short presentation on an important project involving the development of a standardized surveying guide for the Departments of Transportation. Excuse me. We're fortunate today to have Greg Laws, principal and owner of Point3D. Greg is a pioneer and expert in laser scanning and 3D data capture. He has over 20 years of experience with international engineering and construction firms and mentors on industry technologies. Nathan West, Point3D sales account manager, is an accomplished reality capture and geospatial specialist, delivering laser scanning, geographic information, drone reality capture, and integration solutions for new technologies. Moderating the presentation will be David Bonney, channel manager at FARO. David is a geographic information system expert with experience working with the International Space Station, no less, bringing space-based geoanalytics to end users. David heads US distribution for FARO Technologies. So let's do the first poll of the 3 this afternoon. So let me see if I can get this up. Polls. Poll number 1. We're going to launch that right now. Give everybody 30 seconds to what best describes your current role or interest in urban surveying. Okay. Still getting some interest here. I'd like to be sure we know what audience we're talking to, if we can make some adjustments here and there. Okay, seems to have, still coming in. Okay, let's end the poll, share the results. Fairly well distributed. The 2 keys are surveyor or civil engineer and reality capture specialist. So we're going to close that. Go on to the next slide. So I'm a member of a team led by Mike Olson at Oregon State University. We're in the process of developing a standardized surveying guide for all of the state departments of transportation in the US, and we can use your help. More about that in a minute. The first objective of the guide is to create a standards-based surveying and mapping guide for the DOTs that emphasizes, here's the key, positional accuracy, the National Spatial Reference System, and what's called the deprecation of the US survey foot. The US survey foot is gone. There is no more US survey foot. The second objective is to help agencies determine the appropriate level of accuracy for a given application. This is really a key issue. This will ensure geospatial data are reliably and efficiently captured, shared, and reused. Just to give you a sense of where the guide fits, down at the bottom, the foundation of everything is the NSRS, National Spatial Georeference System. That's the NGS's responsibility. That's the geodetic control. On top of that, we see the FGDC, Federal Geospatial Data Committee, is updating their geospatial standards to be compatible with NSRS, so we can rely on those. We don't have to reinvent the wheel there. On the third level, this is a new concept. We'll have to take another webinar to talk about this, but it's the third level is a surveying data model that would create a unified, integrated asset management system for all the DOTs. The new surveying guide will build on all of these three levels. For those not aware, the National Spatial Reference System, NSRS, is undergoing significant modernization to improve geodetic accuracy across the United States. There's four major things going on here. One, correction of the systematic errors from NAD 83 and NAVD 88, which get worse every day. So we're going to have an introduction of four new terrestrial reference frames. All the state plane coordinates, for instance, in the United States are going to change, some by a lot. So you've got to get on board with this and know what's going on. Perhaps the biggest challenge is going to be the shift from ground marks to GNSS. There's no more monuments. The NGS is not going to maintain monuments any longer. This is all going to be done dynamically on the fly. And to try to make better accuracy of the vertical datum, it's going to be gravity-based. So major stuff. The guide is going to prepare really and focus on the future. We're looking to implement this by 2030, let's say. It's going to have, there are just some of the topics. These are just some of the topics that we're going to address. I think you'll agree it's a very exciting time for the surveying profession. So let's get a few of these up here. Most people are familiar with the first three. Robotics, of course, another brand new item. Low Earth orbit satellites going to revolutionize satellite data collection. Autonomous vehicles, don't have to tell you too much about that either, I don't think. Of course, AI and machine learning. Agents that come out of AI, something called the blockchain, which I'll tell you a little bit more about. Data, you hear all the time that things are data-driven. Well, that's not really true because it's the people who write the rules that are getting the data that they want. So data is not the driver, people are. And we need engaged champions that want to lead the US forward in the 21st century. Organizational change is hard, but in this case, it's got to be done. So just quickly on blockchain, once again, we could spend all day webinars on this issue. My son's a much better expert at it than I am. Blockchain, this is the idea of immutable technology. It's among the most promising things being developed. This is the software platform that cryptocurrency transactions are based on. From a surveying point of view, blockchain addresses the number one issue for surveyors being asked to share their data. We all know what that is, trust. The good news is all changes in a file are automatically added to the ledger or the provenance of the data when you're using blockchain. In addition, it supports smart contracts, which enforce rules about data quality and use. You're going to hear a lot more about blockchain and you're going to like it. So our team needs your support. If you're planning to attend GeoWeek 2026, would like to be involved with developing the guide, we want your input. Please let me know. I'll have my email address at the end and get in touch. Okay, poll question number 2. Let's slide over to that. Polls. We got to get back here. Poll number 2. Launch that. Okay, which topic has been most relevant to your current project so far? Mobile mapping systems, cost-effective data capture, SLAM, workflow automation, CAD-ready deliverables. Give you another 10 seconds or so we keep things rolling. Okay. Looks like CAD-ready deliverables from 3D data. That's a very old requirement. That's what that's the holy grail right there. So the rest are pretty evenly distributed. Let's get out of here. And we're going to turn it over to Point3D for their case study. I'm going to stop sharing and turn it over to Nathan West. And there he goes. It's all yours, Nathan, or whoever's going to speak. David, maybe, or Greg.
Yep, thanks, Gene. Make sure my screen is working here. Yep, good to go. So I'm going to do some quick introductions about FARO and just some of the tools discussed in today's webinar, and then I'll turn it over to Point3D, who really put in the effort here on capturing some data very innovatively and pulled out some very cool measurements that we'll show at the later point in this presentation. So Nathan, next slide, please. So just a note about FARO, of course, if you've been following our company history, we were recently purchased by AMETEK, so that happened in July. So that was announced to the markets, and we are officially part of the AMETEK family, as they say. But just some quick history on FARO, right? So we've been around the markets for about 40 years. We started in the medical field, surprisingly, and moved kind of into the industrial space where we are still prevalent in. So what used to be medical equipment turned into a measurement tool that we use in the industrial space. And then from that, we acquired some companies through the years and moved more into the AEC and the public space as well, public safety space. So since then, we've got a lot of tools, and we'll kind of focus on a couple of those today. So next slide there, Nathan. And yeah, just to kind of talk about AMETEK, because it does come up quite a lot. FARO is kind of in what they call the ultra precision technologies group, which is a great sector to be in because of the two other companies that we share a space with, which is Creaform and VeerTech. And we are going to be using these two companies to help leverage what we already do at FARO and vice versa to help these other organizations move products throughout the market. So if you have any questions about these other two companies, feel free to shoot those over. Next slide. As Gene noted, I'm David Bonney. I am the distribution manager for the AEC space at FARO. So I just wanted to put a slide quickly to show our distribution channel throughout the world. Obviously, I focus in the Americas region, the US region, but you can see we are well represented throughout the globe. So if you are looking at FARO as an organization, you can reach out to one of the partners in one of these local areas. So as I mentioned, FARO's kind of changed course over the years. And so you can see kind of the three business segments that we work in, 3D metrology, AECO, and the public safety group. So again, three very different industries, but we do focus on measurement, right? Using some type of light or laser-based scanning devices to assist the public and our commercial partners around the world in these three segments. Today, we're going to talk about more of the AEC side and just kind of what we can do with these tools that are probably a little bit out of the box and the ordinary from what we're used to seeing. So next slide. So at FARO, through acquisitions and through our own development, we look at all of our manufactured hardware as tools. So we look at different tools that can solve a job. So we kind of think of things as a tool case, right? Something that we can bring to a site to solve a problem. So on this slide, you can kind of see the three solutions that we offer kind of in the AEC space, as well as a company called Sitescape that we picked up in 2022. But as far as hardware goes, this is what FARO is known for. So on the left side, you can see the FARO Focus Scanner, which again has been around for about 20 years through different names and channels, but essentially today it is still one of the leaders in that laser scanning market. Very high accuracy, very easy to use. We've kind of been in that field for quite a long time. And then in 2022, we did purchase what's called GeoSLAM and developed with that team what's called the FARO Orbis Premium, which we will focus on in this presentation. The Orbis Premium is a handheld SLAM solution. So on the next slide, I'll go through that. And then just to quickly talk about the Blink, which was announced this year as well, which actually uses SLAM in some of the scanning capture point of view, but it is technically a terrestrial laser scanner with really good cameras as well. So next slide, we'll talk about Orbis Premium. So the Orbis scanner, again, is a brainchild of the GeoSLAM product line. And I see some questions coming in, and we'll touch on those at the end of the presentation. But the Orbis hybrid scanner is what we're kind of calling it because of the fact that when we introduced this to market, Focus was kind of the bread and butter for FARO, right? So we wanted to introduce some of those capabilities in the Orbis scanner. So what that allows you to do is while you're walking through your space to capture your data with your mobile scanner, you then can stop, take a 15-second terrestrial scan. So you can get much more data, higher precision at that location, something unique to the market when it was introduced a couple years ago. And then since then, we've been kind of developing workflows and better cameras and things like that throughout the past 24 months. Next slide. Just another slide on the Orbis Premium. So you can see it is a mobile scanner. It is handheld. So we're scanning with a handle, but that handle is removable. As we'll see in Point3D's presentation, we can use that in different methods. So on the right side, you can see it comes with a monopod. So it's a single hand pole. You can put that on a car. You could technically fly it. I mean, you could put this on any type of equipment in order to do data capture. And our SLAM is the most robust on the market, which allows you to get into environments that you normally wouldn't with a laser scanner. Next slide, Nathan. And then just to talk quickly about our software solutions. So all these that you're seeing on the screen can work with all of our laser scanners, but in the focus for our Orbis Premium. The FARO Stream app is a phone or iPad app that's used to capture data, right? It talks to all of our scanners, there are all three of them, and you can then capture data and see that data captured, whether you're doing stationary scans and need to do pre-registration, or with the Orbis where you're walking around and it's showing you that data capture. From that, you would go into our Connect or Scene software where we actually are putting all that data together and creating the point cloud. You can do data cleanup, some decimation, whatever you need to do to get your point cloud to a final kind of product. Moving from there, you want to be able to share that data. So FARO introduced SphereXG a few years back, which is our cloud platform, which I'll talk about in just a minute. And then products like As-Built that we use to do some modeling, both within our own software and within AutoCAD products. So next slide. Just talking field to finish with the Orbis Premium, we make it very simple, right? You pick up this tool. We do recommend training, but I do say it's not as intense as some of the other laser scanners on the market, right? So we really truly say you can pick this thing up on day one and capture data. That's the easy part. From data capture, you can move into, as I mentioned, Scene or Connect, but in this case, Scene, to do all your processing, getting the data to a workable point cloud. So once you do that and you get it to the status that you need, we make it very easy to then move into third-party programs. So you have listed here TopoDOT, Autodesk, Bentley. So we make it very simple to convert this point cloud into a usable file that other third-party softwares can take. All right, next slide. Lastly, I'll just talk about SphereXG, and I think Point3D will also cover this as well. But essentially, it's a collaborative tool. It's a cloud-based platform so that we can push our data both from the scanner, if you want to do data processing in the cloud, or just from our Connect or Scene platforms to push that data up, do maybe some additional analysis on it, but more importantly, just collaborate with colleagues and customers. So it truly is a centralized hub. And any changes that you make on either side of that, meaning if I make a change in scene, I can then push that change into the Sphere cloud, which is very powerful if I want to then use that data in an Autodesk cloud or somewhere else. So we can make that very simple hub to share that out to the world. So with that, I think Nathan, you'll jump in here. Appreciate the time, and I look forward to answering some questions at the end.
David, thank you. This is Greg Laws, and I am a co-owner at Point3D. And for those of you who do not know us, we specialize in 3D data capture and technology and services. We provide solutions from a number of trusted partners, with FARO being our cornerstone partner. Next, Nathan. We sell handheld mobile imaging and tripod-based laser scanning, all the systems that David highlighted as he was going through the hardware. As part of the sales, we provide pre-sales and post-sale support, training, consulting, and advanced services like data processing. Next. We bring our expertise to a range of markets, from AEC to commercial building, infrastructure, industrial, and manufacturing. Next. So we're here today to talk about a combination of an innovative capture solution from FARO, the Orbis, and TopoDOT. For those maybe not familiar with it, it's a point cloud processing solution for creating 3D models, and specifically what we're talking about today, transportation, civil related. It's a comprehensive solution for feature extraction and geospatial data management, and specifically for the urban surveying application we're going to be talking about. And now to you, Nathan, and Nathan's going to talk about the application and the project that we executed here.
Hey, everybody. Thank you, Greg. With a combination of mobile mapping and feature extraction that has been around for a while for large-scale road, rail, and utility mapping projects, they're very expensive. They require deep knowledge and expertise to operate effectively. They're very complex, very expensive. Executing on smaller scale projects, your medium to small scale, it presents challenges that include the cost, complexity, the physical limitations. It's just not practical for small scale projects to be using these huge, expensive train mounted or large vehicle mounted scanners. So our solution is the FARO Orbis Premium in combination with TopoDOT. So with these two, you have a very cost-effective, very easy to use. You don't need a lot of training, and it's very flexible. You can get into tight spaces, so it's perfect for mid-sized projects like urban campus settings. Our work is driven by customer requirements. The effort began with requirements to provide traditional survey deliverables in large-scale urban settings from 30 acres to 100-acre kind of sites. That's where we fit in just perfect. The example we are showing was a demonstration project for the technology and work process using the Orbis. It was a 38-acre site with many of the features that our customers were looking to capture. We performed the capture using the Orbis Premium, car mounted as you'll see. The first step was to drive the site, to plan our route, pick out where targets should be placed. And then we placed those targets, planned and captured 2 scan loops through the space that provided a point cloud and panoramic image data. In a real project, we'd have added additional loops for more complete road capture, but this one, it was a good proof of concept. This is an image of the Orbis Premium on a FARO vehicle mount, capturing data while driving at around 15 to 25 miles an hour. The picture to the right is one of the images captured along our route. One image is captured about every second along the trajectory, so you get pretty thorough coverage. The vehicle mount is a plug-and-play solution from FARO. We are working with clients on custom solutions for field vehicles, like truck front bumper mounts and raised kind of mounts. It gives improved coverage if you want it to be facing a certain direction or if you want lower angle of incidence. It essentially shows how very versatile this instrument is and can be deployed in many configurations. Planning is a huge part of the field process. So this image shows the Google Earth. We use it to plan local and global loops. It looks complex, but if we were talking with you, it'd be very simple. And we also give you control point collections. We want to share those through some of our loops. It's important to break the site into subregions, as you see. You plan your vehicle and walking areas, and you plan scan overlap for effective registration. You want them to share some common features so you can register them together easily. And then you collect control points in the overlapping areas. It helps tie everything together really tight. The FARO Stream app is an integral part of the capture tool set. It controls the Orbis scanner and provides real-time feedback as you're driving or walking. It works with iOS or Android phones or tablets. The image on the right shows trajectory path is displayed as you walk or drive. The trajectory will also locate flash scans, high-res panoramics, or your captured control points along that path. So you know exactly what you've captured, make sure everything's looking how it should. An added benefit of Stream is the ability to upload directly to the FARO Cloud app, Sphere XG. Saves a lot of time, so it can be processing as you drive back to the office. It's pretty nice. This image shows our project scan from one loop in a grayscale mode, colorized by elevation height. This ensures that all the data is collected and shown. This is the format used in the TopoDOT project. The elapsed time was about an hour for setup and capture. Drive time was about 20 minutes to capture all the points and panoramic images. The application we're showing here is FARO Scene. This is used for scan processing if you're not doing Sphere XG. The image shows a scan from one loop processed in color. In addition to colorizing the point cloud, the Scene software performs additional filtering. Points at a high angle of incidence are filtered out when colorizing. The color format can be used in planning and civil applications, aiding in feature identification. Scene is also used for registration, which we'll show in the following slides. One registration method is cloud-to-cloud alignment. The system will perform a top-down rough alignment and then a fine alignment. You can align based on mobile data or denser, more accurate flash scans. Scene also supports alignment to target. In this case, large black and white pattern targets were used to align separate scans to survey control. In walking mode and handheld, ground control points are captured with the Orbis are used to align the scan to survey control. These methods can be used to align 3D models and 2D plans to your scan data. Very, very useful, very powerful. This image shows one of the large black and white targets off to the right. Targets were spread around the whole 30-acre site for overall control. Along with black and white targets, we were testing large reflective targets that have been used successfully in walking and drone capture. Targets will be located with conventional survey control. Targets can also be used for scan-to-scan alignment and cloud-to-cloud. This is so you can take very, very large, hundreds of acres, scan them in sections, and bring those scans together very tight. This image shows a black and white target setup captured using the flash scan. It's a capability using the Orbis, as David discussed. It's a high-resolution scan captured in about 15 seconds, gives a panoramic image at about 72 megapixel, and a very high-density point cloud. The target shown in the center of the image is an 18-inch by 18-inch And the ideal distance to any target from a vehicle is about 15 to 30 feet. The last step in processing is to publish to FARO's collaborative platform for reality capture data sharing, SphereXG. Here we are looking at a plan overview that shows the scan and image position captured along the trajectory. You can see the flash scans. Various 2D or 3D modes are available for easy project exploration, as well as integration with 3D CAD models. This is the view that comes up when you click on an image along the trajectory path. And this is easily shareable through a link in anyone's browser. This is the same image on a split screen mode showing both panoramic and colorized point cloud data. Anyone can measure and annotate in these views. Very powerful collaborative powers to anyone with a link. No software to download, no screaming fast computer, just your everyday browser. Here we see the data formats that can be exported from scene and the typical applications that use those export formats. This project used the grayscale E57 for the TopoDOT feature extraction and E57 color format for visualization in SphereXG. Moving on to data extraction. This slide shows typical infrastructure applications for data extraction. For building modeling, we might use FARO as built. For contour extraction, we might use Autodesk. For this urban surveying application, we're using TopoDOT. The value that TopoDOT brought to this project was their work process for break line extraction, service modeling, and asset identification. The software supports quick interpretation of point cloud data into CAD-ready results, that's what everyone wants, is what are we delivering? TopoDOT software is layered on MicroStation, but delivers a fully compatible Autodesk deliverable. So whichever way you go, MicroStation or Autodesk, you have something to deliver. A section of laser scan data set was processed with the following information extracted: break lines, 3D modeling in buildings, ground surface modeling, contours, and mesh surfaces. This example shows one of the semi-automated tools for feature extraction. This example shows break line extraction on curb line. It's a complex feature, but with TopoDOT, it's made simple. You define the feature template, tell the application where the break line is, guide it through each unique section, and the application will sweep the profile through the curve or path. And we'll let it finish with AI. Really simplifies, makes it very fast. So the Orbis will collect the data in an easy way, and TopoDOT will help you extract the exact data points that you need in an easy way. This image shows the more complete feature extraction of the area around the building. You can see created break lines, the build-in modeling. These next two slides will show the specific CAD deliverables. Here's the line work for roads, curbs, and buildings, along with contour lines. Here we see the mesh modeling and a ponding study. Who knows what else you can pull from this incredible set of data? You can pull ponding out of this. It's a great data set, and TopoDOT's a pretty powerful data extraction tool. In conclusion, Orbis Premium Mobile Mapping is an ideal solution for small to medium scale projects because it provides more complete coverage, provides flexibility. You can drive, walk, mounted on anything. You can capture both exterior and interior, giving comprehensive architectural and engineering models, provides opportunity for cost savings over traditional methods, and it improves safety by capturing more remotely, keeping your employees out of roads, off scaffolding, and out of harm's way. This concludes our presentation. I'm going to hand it back to Gene.
Thanks very much. Great information. I'm going to just share my screen here. And we're going to get over to poll number 3. Okay. And in poll number 3, we have our final poll. What can FARO do for you next? So here are our options. Provide me with a quote, schedule a demo, more information, give a few more seconds here to wrap this up. Got some questions that came in that we'll get to. Some pretty interesting comments, I think. So I think that does it. And the poll, share the results. And provide me with more information, and nothing at this time. Are the meeting results there? Okay, so next is our Q&A section. Nathan, do you have some of those chat questions that we can take a look at?
Yeah, we can talk about the limitations on the Orbis. There's a couple that kind of asked about that with the resolution and scan.
Yeah, go right ahead.
It goes out to 120 meters, so it can reach out pretty far. It gets 640,000 points a second, so you get pretty good density. I think that's a resolution that someone was asking about. The size of it, I think you're asking about the weight. It's about 5 pounds. You do have a data logger on the side, so you're carrying the tool itself, but it is attached to a data logger that you're wearing on your side. Someone's asking about the max speed. We do want to say about 25 miles per hour, because much faster than that, you're losing data density. It's hard to tell where certain surfaces are. The additional box next to the Orbis on the vehicle was that data logger that I was just discussing. So you have the scanner in your hand, about 5 pounds, and you have a data logger on your side. It's a little bit lighter, but with the battery, about the same. And someone's asking if we can do a flash scan on the Orbis when it's mounted to the vehicle. Yes, you can, because you're controlling it from your phone or tablet. You can initiate a flash scan from inside the vehicle. Very easy to do. You can georeference the process scan in scene. There's a few different methods. We can discuss that more. There's some simple methods, more complex ones, but it's not too hard to do. You can definitely place it on Earth. And someone's asking about a recording of the webinar. We will be providing a recording of it to everybody. And if you're looking for someone who's putting they're looking for construction documentation capabilities, we are 100% all about construction documentation. If you reach out to us after this webinar, we can send you more information. We have white papers on this. We have proof cases. We're happy to answer that. How clear is the point cloud and interior building scans? It's very clear. It's just as clear as the exterior. The SLAM algorithm got its start in mining. So we got started with GPS denied environments, enclosed environments, and having to maintain accuracy for people's lives. So we got our start there. So you know that we're good indoors inside of a building. We can create Revit models very easily. Someone's asking, how long can we scan per battery? That's about 3 minutes per battery percentage. I think it might have, with the Orbis, we dropped a little bit, so maybe 2 per battery percentage, but you got hours. You have like maybe 2.5 hours per battery. Whenever we sell you one, we always try and offer an extra battery, so you get all day with 2 batteries, you can scan. We have another question about floor plan creation. There are many different pieces of software that can help with floor plan creation. FARO has a brand new floor plan, like that's what they call their piece of software. It's pretty nice. They're still developing it, but there's a lot out there. Pretty easy to make floor plans off the point clouds.
David, can you jump in on that floor plan question since you know a little bit more about that?
Sure. Yeah. The floor plan that Nathan's discussing is actually on our Sphere XG platform, and it's just a plugin for that platform that allows for automated floor plan generation. So you upload your point cloud, it's a token system, so you buy tokens and then you pay per floor plan. The nice part about that is it doesn't matter if it's a 1-story building or a 5-story building. It's the same amount of tokens. You pay per floor plan, and it's automated. What that means is it goes out to a crew that's actually building those floor plans. It's not automated in the way that AI would go around making little mistakes that you'd have to fix. It's a real person that's actually creating those floor plans for you. And generally takes between 24 and 48 hours, depending on how complicated it is. And just to kind of finalize that point, it's still in beta. It will be announced to the market as soon as we're out of the beta phase.
And then you might be able to help me with this. The model of the LiDAR sensor is a Hesai, and it has 32 data channels. Is that correct?
Yeah.
Okay. Yeah, that was the next question there. And the accuracy of the Orbis, we have a 5mm accuracy in the mobile, but you heard us speak about the flash scan. You hold it still in the monopod, and you let it sit there for 15 seconds after you initiate the scan. And that brings it down to 2mm. It's very, very clean, very nice point clouds coming out of that flash scan. So the accuracy is a little bit variable, but very tight.
And just to kind of finalize on accuracy, that's always a congested one in the SLAM market, right? So when we talk about accuracy, we need to remember the fact that it's only as accurate as the user. So you have to, if you want a more accurate product, you're going to want to bring in control. If you're using the scanner without control, as Nathan mentioned, 6 to 8 mils is pretty much the stated accuracy and what we expect out of the scanner. On something that's driven without control is not going to be 6mm accuracy, right? You're going to have centimeter accuracy, maybe even a couple inches on something that large. But that's why on something like that, Point3D used control targets. That way they could bring all that data together and make a much more accurate final product.
Yeah, of course, your capture environment, capture method will definitely influence your accuracies. Definitely. And someone's asking about cave surveying. Has anybody tried? We have a customer with a bat conservancy based out of Austin, Texas, and they are scanning bat caves. They're down in Mexico. They're all over the place. And we have some awesome data sets that I think we're allowed to share. If anyone wants to reach out after this, we're more than happy to share some of that. It's some pretty cool data. Those are some cool caves.
Yeah, and just James Madison University does the same, and that's data they would also be willing to share. So happy to follow up with that.
Yeah, and someone's asking about mirrors and reflective services. Any LiDAR, anything that's working with light, mirrors, reflective surfaces, they're gonna mess with it a little bit. We have filters that will help filter out some of that noise. There are methods that you can take while you're scanning in the field that can help mitigate some of that. But yeah, it's just the nature of the beast. You're dealing with light, you're dealing with mirrors. It's gonna give you a little bit of some issue. There's no way to get around that.
Nathan, Sphere XG just introduced a beta reflection filter, and we haven't had a chance to test it, but that's something that they're looking at there. So you may be able to automatically remove some of that noise better in the future.
Yeah, I'm looking forward to that, definitely. And then someone's asking about the data capture limited to about 20 minutes per scan. That is recommended. It's not a hard limit at all. We've had people do a 90-minute scan and they came out successful, but it is tenuous to go that long. That's a long scan to have to go back and rescan if something happens. It's a huge data set for a computer to try and chew through. So there's a few reasons we ask you to keep it around 20 minutes per scan. It's not a hard limit. It helps your computer out. It helps your timing out, reliability. So again, it's not a hard limit, but we do still ask you to keep it 20, 25 minutes per scan using the Orbis.
And just to add to that, I mean, think about 20 minutes, how far you can cover walking. Let's just say walking. I mean, you're doing multi-stories in a building in 20 minutes. So it's a lot of data, as Nathan pointed to. So it's easier to keep data, manageable, and you can always put it together, piece by piece later on.
Mm-hmm. And someone's asking about shoreline. I've seen a few people do shoreline scans using the Orbis. It's more about steady features. If you have it pointing at the rocky shoreline, it can see those large rocks. It can keep itself with that. If you have it pointing out to the moving ocean, it will lose itself. So it's best practices. You can scan shorelines, but you got to know what you're doing. Gets tricky.
And that's something where the flash scan might come in handy, because you can use the flash scan and limit what you're using for registration purposes, as opposed to using the whole scene that the mobile scan will be capturing.
Mm-hmm. And someone's asking about independent checks on the final point cloud accuracy. We ask everyone to do that, especially if it's an important project. Please have some checks in there. We rely on this. Like 99% of the time, it's going to be correct, but that 1%, you want to know. So yeah, do your checks, get your reliability, get your confidence. So yeah, it's a standard in any kind of drone capture, SLAM capture, any kind of general capture. You want your quality control checks, of course.
The simple check, if you're just dealing with the SLAM data, is 2 scans of the same space. And if they overlap in all 3 planes, X, Y, and Z, then it's a good chance everything is lining up well. Another simple test is throwing in black and white targets in the scene and being able to measure at discrete points. And if the targets line up from scan to scan, or even better, if the targets line up to your survey data, you've got that check of how accurate it is.
Mm-hmm. And our next question is single return or multiple. We do a single return with SLAM. I don't know anyone that's doing multiple returns because it gets confusing. For the sensor itself, for the algorithm, you want one return. You want to know the time of flight, the phase shift. You want to know what that beam is doing exactly so that you can build your environment accurately. You start introducing multiple returns, you're going to lose your accuracy. You're going to lose your SLAM reliability. So it's only single return, just so we can keep everything nice and tight. And then there's a question for David. Is it possible to leverage the floor plan creation from Horizon RT scan data?
Yeah, that's the best part about Sphere XG is it's not sensor dependent, right? It's agnostic to any sensor. You could bring Leica data in, Trimble data, it doesn't matter. So as long as it's, now keep in mind, the data you put into the system is the accuracy you're going to get out, right? So Horizon data is noticeably noisier than Orbis data, but it's still a great, fantastic product, and you will get an accurate floor plan. Just keep in mind that's not going to be as accurate as a Focus floor plan. So yeah, absolutely can use the Horizon.
Yeah. We have a question about cost. Please hit us up after this so we can meet with you to look at your specific needs, because it applies to a lot of different kind of aspects. And so we want to make sure you're getting the right product, either software or hardware. So we'll talk to you about cost afterwards.
But on that note, FARO is running some compelling incentives on the Orbis Premium, so please give us a call.
Yeah, until end of year, they have some pretty good dealer discounts, or manufacturer discounts, excuse me, straight from the manufacturer discounts till end of year. So please do reach out. And someone's asking how to reach out. We have it put up right now. The slide that you see, we have some email addresses that you can reach out to. You should be able to find our phone numbers through point3d.com. Should be pretty easy. And someone's asking about calibrations. We have some people that have had a Horizon for years and they haven't calibrated it, and they're still getting good data. It depends on how often you use it, how hard you are on it, how often you travel with it, because TSA is not polite to our cases. So there's a few different variables on that. again, some people haven't calibrated at all, and there's some people that they calibrate twice a year. So it's how often you use it, how hard are you on it. And then independent checks on presented data set and sharing results. Yeah, we'd be happy to sit down with you and we can go through the data set we showed you. We haven't done any particular checks on it, but we can go out, gather that data. So yeah, please hit us up afterward. And then someone's saying they have a Orbis first gen. Can it be upgraded to a premium? David, do you want to handle that question?
Yeah, it can't be upgraded in the sense of we can't swap cameras out. The sensor and the camera work independently, but they are kind of manufactured together. So we can't upgrade that sensor. We could do some kind of trade-in for an Orbis Premium. That's something that we can do.
And there is a backpack option to transport the scanner. It's pretty cool. Are they still doing that transport backpack and scanning backpack all in one, David?
That's a good question. I don't think so. I believe when we switched over to Orbis, they came out with a separate backpack for that, which is really truly a transport case. And then we have a more rigid backpack that you would use for, out exterior capture when you need to walk and have hands free. So there's generally two for that.
Okay. So yeah, they have pretty good options for any kind of situation. I think we've come to the end of our questions.
Yeah, that was a great session, one of the best. Thanks very much, Nathan. Really appreciate it, David. So I want to thank everyone for attending and for your interest. If you could take a couple minutes to answer a few of the exit survey questions, we'd really appreciate it. And as we have mentioned a couple times, everybody who's registered will get a link to the webinar I believe we have it set for 2 days. So once again, thanks very much, and we will look forward to seeing you again. Thank you.
Thank you.
Thank you, everyone.